Welcome everyone, and thanks for attending tonight's webinar. My name's Talia Newton. I'm the Climate Emergency Project Officer at Basco Shire Council, and I'll be the MC for tonight. I'd like to start by acknowledging the Bunurong and Gunai peoples as the traditional owners and custodians of the lands and the waters that I'm on, and I'm sure many of you are too. I'd like to pay respects to their elders past, present and emerging, as well as any Aboriginal elders of other communities who might be joining us tonight. If you're joining us from elsewhere in Victoria, feel free to introduce yourself and acknowledge the country you're joining us from in the chat. Tonight's webinar, Designing for Resilience, is part of a series of webinars that Bass Coast and South Gippsland Shire Councils have partnered with Renew on across 2025. Renew has been working in the sustainability space for over 40 years as an independent, not-for-profit body with a mission to inspire, enable and advocate for people to live sustainably in their homes and communities. This webinar and all the other webinars throughout the year will be recorded and made available on the CAP, the Community Action Portal, for future viewing. Our 2025 webinars are designed to equip you with the information and knowledge to make your households cheaper to run, as well as more comfortable, efficient and environmentally friendly to live in. So without further delay, I'd like to welcome our expert presenter for tonight, Anthony Demars. Anthony from Demars Architects is a Fellow of the Australian Institute of Architects with over 30 years experience, specialising in residential and education projects. He's known for sustainable practices and contemporary design. He's passionate about design's positive impact and advocates for sustainability, responsible resource use, and urban renewal. Anthony is a contributing member to the Australian Architects Declare movement since its inception. In his spare time, Anthony enjoys helping his son enhance the energy efficiency of his Thornbury home. Welcome, and over to you, Anthony.
I assume you can all see me. Thank you very much for that fantastic introduction, and it's a privilege and a pleasure to be here. So just by way of introduction, I'm an architect, as Talia said. I've been working for some time. I graduated in the late 80s and essentially have run my architecture practice for over 20 years, done a lot of residential work, seen a lot of changes in the industry. We've become much more focused on sustainability. There's a really strong link between sustainability and well-being. So generally speaking, a house that performs well from an environmental point of view is generally speaking a healthier home, and the benefits that flow on from that are, in my opinion, houses that are easier to live in. They're healthier homes to live in, they're more efficient homes to live in, and generally speaking, they cost less. The principles of designing sustainable homes have been with us for quite a long time. More often than not, they are common sense, and there's a lot of knowledge out there in the public domain. So tonight's topic is called Designing for Resilience, so let's get into it. So what we'll cover is what is resilience and why it's important, the fundamentals of passive solar design. I'm sorry you can't read that super well, but I'll certainly talk through it so that everyone can understand what we're talking about. Resilience through retrofitting. Retrofitting, more or less, is about adapting your existing building and your homes for new uses and improving the functionality of those dwellings. Resilience to extreme events, fire, flood and storms. And anyone who's following the news will know that floods, bushfires and storms are becoming more frequent, and more we need to plan for these things to the best of our ability. And then we'll finalise with some case studies of some projects that I've been involved with. Very happy for it to be interactive. So if you do have questions, you're welcome to ask me. I'm very happy to answer questions. It's probably how I prefer to work, if I'm honest with you, because I feel like I can answer most people's questions. but for the purposes of the exercise, we'll make a start. So part one, resilience and our homes. Essentially a resilient, if we go back a step, a resilient house is one that's sustainable, adaptable and scalable. We're really talking about houses that can, that are responsive to the situation that we currently find ourselves in. And so what we're finding with climate change and changes to the to weather patterns is that the environment is less stable. So we're getting more extreme events. We're getting hotter summers. We're getting more rain during the colder months. And, the winds are stronger. Everything's just become ramped up over the course of the last 20 years. So a resilient home, as you would expect, is something that is responsive to those situations. So it's disaster resistant, it's affordable, it's sustainable, it's locally appropriate, it's healthy and secure, it remains a financial asset, it's adaptable and scalable. Now, I suspect not all houses can meet all of these criteria, but, it's fair to say that houses that are working in this direction are going to be better assets in the long run. If you think about a very big, clunky old house, generally speaking, it's not very resilient. But if you think of a small footprint house, well-designed, energy efficient, adaptive to changing needs, then that's what we're talking about when we're talking about a resilient house. They're durable because they don't require excessive maintenance. And maintenance of a large house is a very costly thing. The materials that we use, if it's painted surfaces or natural timbers, they generally require more maintenance. Low embodied carbon. Embodied carbon means essentially the amount of carbon that is required to manufacture any particular building industry. So whether it be concrete, timber, steel. So anything that requires a lot of energy to produce and a great distance to travel in order to get to your building site is what we refer to as embodied carbon. So generally speaking, things that are local to your area, things that are grown naturally like timber are generally low carbon, and things that come from a long way away and require a lot of energy to produce, like aluminium, is generally what we think of as high embodied carbon. The reason why we think embodied carbon is really important in our homes is that it's a really easy way to reduce our carbon emissions. So at the time that you're building your house, if you're choosing low embodied carbon materials, it means that you're doing a much better job for the environment. Then there is operational carbon, which is essentially how much it costs to heat and cool your home. And if you have an energy efficient home, it generally means that you have less money needs to be expended on your gas and electricity bills. So there's a benefit to your financial well-being if you have an energy efficient home. The fundamentals of passive solar design. So passive solar design is a concept that's been around, as I say, for about 30, 40 years, probably even more. And it essentially is using the effects of summer and winter sun and the fact that, the sun rises in the east during the midday, it's in the north and sets in the west. Generally speaking, in summer, the nights are cooler. Generally, in winter, the sun angle is much lower, which means that we can get our sun penetrating into the living rooms much more easily. So we're essentially trying to use the natural cycle of day and night, summer and winter, spring and autumn, to use those natural systems to naturally heat and cool our homes. It's essentially a resource that's available to all of us. And by making better use of passive solar design, we essentially can reduce the amount of energy that we need to put into heating and cooling so that, it again reduces our energy costs. It also means that we have homes that are more or less responsive to the environment, and that's a good thing. So it means that we're just working in with nature to the best of our ability. For those who are interested, it essentially came about during the oil crisis in the early 70s, where architects and engineers were really thinking about how can we design our homes to be much better and reduce less energy and not need as much energy in order to heat and cool. A passive solar design maintains a comfortable temperature in the home. It's climate responsive, it's energy efficient, and it's environmentally sustainable. Okay, so ESD. So generally speaking, we orient our buildings to the north, the living rooms to the north, so that we can get that nice warm winter sun when it's generally colder. And by having an eave overhang, we can exclude that really hot summer sun and keep our houses much cooler. The benefits of a solar design, a passive solar design, is that the health and well-being is improved, because essentially we've got a home that is responsive to the climate, and we're reducing our energy costs. The main principles are that we're using passive solar heating and cooling for our homes, and we're using thermal mass. So I'll just talk a little bit about thermal mass. So in winter, if you've got, say, a concrete floor in your home and that winter sun is coming into your home, that energy that is being gained from the sun during winter is actually heating up the concrete or brick wall and can re-radiate back into that space at night. So thermal mass is a really important consideration when we're talking about passive solar design, because it's essentially storing the energy that's coming in from the winter sun and re-radiating that heat back into the living spaces. Glazing is really important, not having too much glazing to the east and the west, because generally speaking in summer, we're getting a lot more solar heat gain from those two areas. So the amount of glazing and the type of glazing that we put into our buildings is really critical. And there's been such a lot of advances in glazing technology that you can get things like low energy, low E glass, which excludes the summer sun, obviously double glazing, triple glazing, and much better window frames than we would have got, say, 20, 30 years ago. So we're getting high-performance glass and high-performance windows, which is making a big difference to the way in which our buildings are functioning. Ventilation and air tightness. This is really important when we're talking about passive solar design. So generally speaking, what we're trying to do in a passive solar design is let's say it's summer, and generally speaking, it's cooler at night. We want to open up our buildings so to let that cool air flow through the buildings and allow the heat of the day to sort of be taken away from the building. So that's a really important consideration. So generally speaking, in a passive solar design house, we orient our bedrooms to the south, or our bathrooms and wet areas to the south, and we put our living rooms to the north. But we design a home that can actually get some cross ventilation through the building. So having openable windows, skylights and things like that just really helps with the heat load. Air tightness is a bit contradictory to ventilation, in that when we seal a building up, when we actually want to keep the heat in, we don't want buildings that are really leaky. So we want to have good seals around windows and doors through things like light fittings, power points, and all those sorts of things. It's an area that we've really improved on over the years. So again, if you go back 30 years, 20 years, our buildings were very, very leaky. And by having a leaky building, basically you're just losing all of that warm air if it's winter, or cool air if it's summer, to the outside. So insulation and air tightness is a really important factor in keeping the heat and coolth that you've got in your house. Passive house is a different standard. We'll talk a little bit about that later, but essentially that's a much higher application of passive solar design principles. It's important to understand that in Australia, I think we have 6 climate zones, and generally speaking, in the south of Victoria, we have essentially 2 or 3 zones. We have an alpine and we have an arid zone up into the north of the state. But generally speaking, in the areas that this webinar is going to, we've got a fairly temperate climate. We've actually got a very, very good climate in the south of Victoria, in the sense that it doesn't get so hot and it doesn't get so cold. I know lots of people like to complain about the weather, but in reality, I think we have a really good weather system in our in the places that we live in. So it's actually very easy to design homes that have a connection to the outside, and that we're not having to deal with really severe conditions of really cold and really hot climates. So that puts us at a distinct advantage. But each zone that we're designing, so if we were designing in Darwin or Queensland or Western Australia, then you would expect that the type of design that we do for those houses is going to be different for each state. And a good way to understand design for climate is just looking at your local area, looking at what buildings actually work, what buildings don't really work. Buildings with eaves, buildings that don't have huge amounts of glass in them. So about 30% of the wall area, no more than 30% of the wall area should be windows. The size of the house, the orientation of the house, the landscape makes a big difference to how we respond to climate. Understanding humidity and the amount of solar heat gain that we get in summer and winter is really important when we think about designing for climate. Generally speaking, good architecture is architecture that responds to the climate. These diagrams probably more than anything explain passive solar heating and passive solar design. And put simply, in summer, the sun is much higher in the sky, just because of the way the Earth is tilted. And that means that we can exclude the summer sun by just having a fairly shallow eave in our buildings. So about a 600, 700 millimetre wide eave really enables us to exclude that summer sun from the windows and walls. In winter, the angle of the sun is much lower. It's about 28 degrees, if I'm not mistaken, in Melbourne. And that means that the sun can penetrate into our space much more easily. And we want that winter sun to come into our buildings because it heats the internal space. We're getting free heating from the winter sun, and we're excluding that hot summer sun in the summer months. Orientation is really important. As I say, we generally speaking orient our buildings to our living rooms to the north, and we try and have as few windows as we can on the western side, because generally speaking, as the sun sets in the afternoon, we're getting, the day has heated up quite a lot. The air temperature has heated up. So the summer sun can really have a big impact on how much heat the building gains once we hit the afternoon. We also have to think that in summer, there's a lot more sunlight during the day. So the sun will rise, 6 a.m. in the morning and, will set 7, 8 o'clock in the evening. So we're getting, 13, 14 hours of daylight, of sunlight. So that's just become something else that we need to manage during the course of the day. This is a little diagram that shows you basically the sun moving around a building, and by applying sun shading around the building and orienting the windows in a specific direction, we can have a big impact on how much solar gain we get from the building, from the sun during summer and winter. Passive cooling. essentially what we're trying to do is increase the heat loss during the cooler part of the day. A really, really simple way of thinking about passive solar design is just simply we're using the effects of day and night and season to design buildings that are responsive to those conditions. So, we know that it's hot in summer, but it cools down in winter. So the easy way to cool down a building naturally is to allow the building to ventilate. So, generally speaking, in those 7 or 8 hours of nighttime, by opening up the building to as much as possible, just allows that hot air to be flushed out of the space and that cool air come into the space. And then you essentially close the building up during the hot part of the day so that you're keeping that cool air in the house for much longer. So cross ventilation is really critical, as is shading, because shading prevents solar heat gain during the hot part of the day. What also goes without say, I think, with all of this is having really good insulation in your building, because the insulation prevents the heat loss and heat gain during summer and winter. Orientation is absolutely critical, as we were talking about earlier. So again, we tend to orient the living rooms to the to the north, and bedrooms to the south. And wind conditions do vary. Generally speaking, in Victoria, the cooler breezes tend to come from the southwest, and the hot, sort of more desert air comes from the north and the west. So those particularly hot, dry winds come from there. But in truth, wind does kind of move around the building somewhat, but the weather tends to come in specific directions. Typically, we organise our buildings so that there are, a deeper eave or pergolas to the north, so that we can exclude that hot summer sun during the middle of the day in summer. It's really important to understand that you may have a block of land, or you may have a building that is not ideally oriented in relation to passive solar design, because the way that subdivisions work, and whether you've got an existing building and the previous designer didn't take into account these principles, that by no means suggests that you've got a bad building. It just means that you have to work a little bit differently. So, for instance, if you have a house that is oriented to the west, that's not ideal, but equally, there are sun shading devices and vegetation, landscaping treatments that can help mitigate against that really hot westerly sun. So, it's not a one size fits all. You can make any orientation work for you, in truth. But, in classic passive solar design, it is about that north orientation that makes the world of difference. Shading is just so critical, and it's just the simplest and easiest way that we can exclude that really hot summer sun. So in this instance, in this photo, I think, a vine, which is deciduous, is a really good example of a plant that actually excludes the hot summer sun, in the December, November, January months. But obviously by being deciduous, it allows the winter sun coming into the living rooms. So, with all of, and this comes back to designing buildings and gardens together. In a lot of newer states, we're seeing much bigger buildings on smaller allotments, which is not allowing us to have the same garden opportunities that we once had. So it's really important when we're designing buildings and thinking about buildings is to include the landscape design into the overall project, because landscape just, it just reduces the it just increases the energy efficiency of a house no end. And if any of you have been in an open car park or, a shopping centre where there are no trees, that the effect of the heat is really, quite pronounced. Whereas if you go into a park and there's lots of shady trees, there's lots of shrubs around you, the ability for nature to absorb the heat is quite incredible. And it has just a real psychological benefit for the people who live there, that we generally feel a lot better when we're surrounded by nature. So when we're designing buildings, we want to incorporate landscape as much as possible. Insulation is, the advances in insulation are just incredible. Like when I graduated, we only needed to put insulation into the roof. Now we need to put insulation into the floor, the walls. Our windows need to be insulated. Our roofs also need to be insulated. Essentially, an easy and simple way of understanding insulation is that it's essentially a blanket that you wrap your building in. It's really effective on the outside skin of the building. So if you think of a building as having 6 sides, we've got the 4 walls, a roof, and the floor. Essentially, those 6 sides are the critical areas that we want to insulate. We're not interested in insulating internal walls or internal floors. That makes no real difference. So the thermal envelope, which is the external walls, are the things that we want to insulate. We measure insulation according to a thing called the R value. So the higher the R value, the better. So, you can get R1, R2, up to R7, I think, in blankets. There's varying qualities of insulation, and they're readily available. The big advantage of insulation is that once it's in your building, it's kind of there for life. You're not having to do anything else for it. So it's quietly working away in the background, keeping your house warm in winter and keeping it cool in summer. So you don't need to turn on the air conditioning, not nearly as much. So having good insulation is, absolutely essential in a well-designed, sustainable house. Thermal mass, we touched on that earlier. I think the principle of thermal mass is really important to understand. Essentially, if you think in simple terms, if you think of a brick and you put that brick, just as a way of explaining the concept, if you put a brick outside and the sun heats that brick, it's absorbing energy. And as the day cools down, that energy in the brick actually re-radiates back outwardly. So if you've ever walked past a brick wall in summer and touched it, it's really hot. And that heat is actually stored within those bricks. So we can use thermal mass in our buildings. Typically, we use it in concrete floors and masonry walls, brick walls internally, to absorb some of that winter heat, and then re-radiate at night. And that's referred to as the thermal lag. So we want to capture that heat in the middle of the day in winter and allow that heat to re-radiate in the space at night. Glazing we touched on earlier. I would just say that, having been in the building industry for some time, the advances in glazing and window technology is just phenomenal. It does cost more to get well-designed windows. There's no question about that. But the benefits are really amazing. So if you go into an older house, single glazed, cheap aluminium windows, essentially, you've more or less got glad wrap around the opening of your building. If you go into a well-designed house with good windows, then essentially the windows are really performing their role in keeping the heat in during winter and excluding the heat during summer. So it does that because we've got much better glass technology. There's a thing called the solar heat gain coefficient, which is the ability for the glass to exclude summer heat gain, and the double glazing, especially if the double glazing is vacuum sealed. It means that the double glazing is providing an insulating blanket between inside and outside. Unlike insulation, we measure the performance of glazing using the U value, which is actually the inverse of the R value. But essentially, the lower the U value, the better the glazing system is. Okay, so you want to get good glazing in your building, and you want to get good window frames in your building because it makes such a massive difference. And a good way of thinking about it is that windows and glazing are typically the weak points of your building. So the better designed the windows are, the better the performance is going to be for your building. So ventilation and air tightness. So it's, as I said to you earlier, it's a little bit of a contradiction because in some ways we want our buildings to be well ventilated because that's how we get fresh air into our houses. And, historically our buildings in Australia are very leaky. So for instance, exhaust fans, air vents, downlights, chimneys, just the construction method, generally speaking, leads to a very leaky space. So if you think about wearing a jumper that's got lots of holes in it, it's the same with a building. By having a building that's very leaky, you're going to lose the heat that you put into your house through the heaters, and you're going to lose all that cool air that the air conditioner is putting in summer. So it's essentially all of that air is escaping. So on one hand, we want our buildings to be airtight to retain all those whatever energy we put into our buildings. On the other hand, we want our buildings to be well ventilated because when, after a hot day, we do want to open up the windows and let that cool air run through the building. So what it means is that we have to manage this issue. We want ventilation, so we want our windows to open. We want our roof lights to open so we can control that ventilation. But when we close those elements down, we want the building to be as airtight as possible so that any heat that we put in because of the heater is being retained in that space for much, much longer. One of the issues that's emerged through having better environmentally designed buildings is condensation can arise from a building that is really well sealed and where we don't have much daylight and sunlight. So, we have to really manage that, and we have to have good knowledge about how we do that. So the principle is that if we have warm air, it has the ability to hold more moisture in it. When that warm air that has moisture in it comes into contact with a cold surface, then condensation can occur. So we get moisture occurring on the inside of our buildings. That's the thing we're trying to avoid at all costs, because when we have moisture on walls, on curtains, on glazing, the opportunity for mold can occur, and that can create an unhealthy building. So ventilation, daylight, sunlight, and having buildings that separate the inside from the outside as much as possible prevent that condensation from occurring. So this is particularly an issue with apartment buildings where we're not getting daylight and sunlight deep into the spaces that are, managing this issue. Talk briefly a little bit about passive house. Some of you may be aware of passive house. So it's a little bit confusing because we've got passive solar design and we've got passive house. They're two words that are quite similar, but they're also different. Passive house is a standard that essentially emanated from Germany in the mid-1970s. Again, it was in response to the oil crisis of that era. And it came about through an institute of engineers, architects, and so forth, who worked out that if you insulated a house, you made the building very airtight and enclosed, that you would require much less heating and cooling within that space. The principles are very much aligned with passive solar design. However, it just raises the bar ever so much in terms of you're effectively getting a building that is a much more high performance building than you would with a passive solar design. So there's certification involved. There's a whole lot of computations that have to be delivered to the Passive House Institute to demonstrate that you've achieved the efficiency that's regarded as a passive house design. Passive house mandates that you have a ventilation strategy of continuous fresh air. So it does this through an air exchange system, which transfers whatever warm air or cool air that you have inside the house through a heat exchanger and brings fresh air into the space. It means that in a passive solar design, you've got continuous fresh air coming into the house at the right temperature. You also have, again, it's lifting the bar from passive solar that much higher. You have high performance windows, external doors that are extremely well sealed and really well glazed. And a key feature of passive house is that all the modelling is done at the design stage. So you have to submit your energy modelling to the Passive House Institute to verify that you meet the standard of passive house. And then when it's built, you have to do testing to prove that the construction and the performance of the building meets the criteria of passive house. So it's setting a much higher standard for the design of the building in order for you to meet the criteria of passive house. Passive house is becoming a very popular design approach in Europe, in Japan, in England, and New Zealand, and it's becoming increasingly more popular here in Australia. I think next week there is the Passive House conference. So they have an annual conference that is growing. The number of suppliers who are meeting passive house standard is growing. The number of passive house tradespeople out there are growing. So it's something that you'll definitely hear more of in the future. I suspect many of you who are on tonight's call are already in a building. So resilience through retrofitting is probably more relevant to you. It's really important not to think of a building as, you design a building, it gets built, and then you set and forget. A building is no different to any other asset in your life, whether it be a car, a bicycle, a piece of computer equipment. It is about how you use the building, how you maintain it, how you repair and improve a building. Essentially, all buildings need to be maintained, and to some extent, a budget needs to be allocated every year for the maintenance of the building, whether it be repainting, cleaning gutters, changing windows, making the bathroom more accessible, a whole range of things. So the more we maintain our buildings, the longer our buildings can be retained for, and the less likely that those buildings are going to be demolished. And I'm sure if you go for a walk in your local area and you see the buildings that are properly maintained with their gardens and the grounds and the building themselves, often they're the buildings that attract a better price when they come up for sale, but they're also buildings that don't require as much cost in the long term because they're being continuously maintained over a long period of time. So behaviour is really important, and the way that you use buildings is really important. It's, again, you can be active in it in terms of how you you get the appliances you use. So, for instance, if you've bought a house and it has a gas fireplace in it or a gas hot water service, it's a relatively easy fix to transfer to transition that gas hot water to an electric hot water system, to install solar panels onto that building, to get a more energy efficient heating system. So these are the sorts of things that you can do in existing buildings. I can't stress the importance of landscaping in the design of resilient buildings, rainwater gardens, having gardens that are permeable, plants that are local, indigenous, that attract, insects and, encourage, I won't say wildlife, but, native flora and fauna, I think is really important. Productive gardens, so gardens that can actually contribute to your kitchen table. So there's so much benefit that comes from having a well-landscaped area in and around your building. The reason we want permeable surfaces, and this comes back to having buildings that are a smaller footprint, is that we don't want to have a situation where stormwater is running off our buildings into the stormwater system and into our rivers and streams. We want to sort of delay that process as much as possible and use that water in the ground to create a more fertile landscape in and around the building. So, so much of our cities now are sealed with asphalt, concrete buildings. So any opportunity that we have in and around the building to create permeable landscape is really important, because it means that water isn't being flushed down the stormwater system and into our river systems. I think it's fairly simple, fairly easy to say that a lot of our homes are not climate resilient or climate adaptive. We've got a lot of work to do in this area. Every time there's a bushfire, a flood, a storm, we hear in the news how our buildings are being damaged. And there's only, to be honest with you, so much that we can do, but it's really important that we do give consideration to these things as much as we can. Resilience to extreme events. It's a bit harrowing, but we are more prone to heat waves, drought, bushfires, damaging storms, strong winds, floods, humidity and mould, and rising sea. And I'm not one to be doom and gloom, but we are seeing these events more apparent, and I think we all of us have a responsibility to do what we can to make our buildings more resilient as much as possible. The recent fires in LA, those buildings that survived, those that didn't, often came down to luck and design. But it is interesting when you reflect on what can be done in order to salvage what we have. And I think we all play a role, we all belong in a community, and we all need to do our bit in relation to these things. Resilient homes have the potential to save costs in the long term and potentially, retain a house that we can live in. Insurances, if you're reading the local press, you'll read that, some houses are becoming uninsurable. Some places are not insurable anymore. So the choice of home that you make, the location of home that you make, I think are really critical. And it just means that your home is being adapted to changing conditions. We are very aware of bushfires here in Australia. Ash Wednesday, Black Fridays, all of these days where we've had major events in and around our building, in our communities, highlight the need to create houses which are bushfire resilient. We have what we call a BEL rating in all of our cities and country areas. So architects and designers have to design buildings that respond to the Bell rating. So Bell is short for bushfire attack level. So if you're in an open area, with not many trees, not much grassland, you're in generally a low fire zone. If you're in a forest, you're generally speaking in a much higher bushfire attack level, and the design has to respond to that. So having fly wire or meshes around the building is common. Smaller windows for high bushfire attack, the sort of materials that we can use in and around the building becomes really critical. This is reasonably well known. It's part of the building permit process, and in truth, can save a home in those more extreme events. I should have waited until I got to this slide, but this explains the different Bell ratings. So the lowest is 12.5 ember attack radiant heat, and the highest is fire zone FZ. So that's where you're at a high risk of being attacked by a bushfire. Generally speaking, where you're adjacent to a forest, whether you're down from the prevailing winds or up from the prevailing winds has an impact. So more often than not, in most communities, we're in about the Bell 19 and the Bell 29 range, where you need to be aware of the bushfire attack due to ember attack, and design a building in response to that. Where I live in Thornbury, when we first moved into the area, there was about 22 years ago, there was a flood because the stormwater system didn't work. And the impact of flood is quite devastating, because it comes in at a low level and can do enormous damage to a house. Carpets, furniture, electrical equipment, all of that stuff gets really badly damaged. So the design of the building, and generally speaking, there are flood zones, which is given to us through the local authorities as to what level we need to design our buildings for. So, being conscious of, how your building will perform in a flood is, really critical. Not sure how we're going for time, but just some case studies. This is some work that we've done. This is actually a passive house design that we've done in Northcote. Environmental design is good design. I think good architects have always done good environmental design. Bad architects don't do good environmental design. Generally speaking, good environmental design is the work that connects buildings to landscape, the use of natural materials, not needing lots of heating and cooling to make the space work, thermal mass, as is the case here, which is really important to this space, and outdoor areas that really connect indoors from outdoors. Windows that are high performance. Gardens. This garden was actually recently, it's actually much more established now, and it was recently featured on Gardening Australia, if any of you are interested, and connects to the local park that's adjacent to it. It's an Indigenous garden. It's a really beautiful garden and provides a lot of really good sense of well-being for the clients who live there. And just being able to change the environment to suit the conditions of it. So blinds, sun shading, not getting that hot summer sun is really critical. And this is it during the day. In terms of resources, there's just a wealth of material, and Renew in particular, I think, are a fantastic organisation for disseminating what good environmental design is all about. Sustainable House Day, we've got last year's date. I think that was just last week here in Melbourne. that's a really fantastic event that, I would encourage you to put your own houses up for Sustainable House Open House Day through Renew. Um, Getting off gas, that's a big part of what we're trying to do here in Victoria, in terms of not needing gas in our homes so much. But there's lots of resources available. A good way of understanding sustainability is just observing what works and what doesn't work in your local area. A lot of it is really common sense, and you don't necessarily need an architect telling you what good environmental design is. It's just we've been trained in it and we do it day in, day out. But, it's about really using the resources that are naturally available to us and designing buildings that respond to those natural conditions. And once you get your mind around that sort of idea, it becomes pretty easy to sort of think, well, how can I actually make this house respond to the location that I'm in? So I'm very happy to answer any questions. I'm not sure if Talia, you're going to come back in. I do need to put in a plug for Renew, but it is a membership non-profit organisation working to transform Australian homes for climate and energy resilience. They have a fantastic magazine that comes out, I think, quarterly. And I think they do a great job in promoting a better response to sustainability and climate change than most other organisations. So I wholly endorse them. So Talia, I don't know how I went, but I see that there are 19 comments. So if there are questions that you might want to fire my way, I'm happy to answer them or take your lead.
Yeah, thanks so much, Anthony. We will get into the questions shortly. I'll just mention a couple of things beforehand, and also Sustainable House Day this year is on Sunday the 4th of May, so it's actually next Sunday. And there are a few houses, or more than a few, I think maybe around 6 houses within Bass Coast Shire Council that have registered. So if you go to the Sustainable House Day website, you'll be able to register for that and go along. And there are webinars as well, so you can go along to the webinars throughout the month of May. That's a really good resource, and that's all run by Renew as well. So if anyone has any questions, please continue to put them into the Q&A. I'll just mention a couple of other things. So tonight's webinar is part of Living Lightly, a series of online and in-person workshops. So Bass Coast Shire Council are partnering with South Gippsland, partnering with Bass Coast Adult Learning, as well as other organisations to cover lots of topics such as energy, food, gardening, circular economy, and you can register for those now. We'll put the link in the chat, and it's on the CAP, the Community Action Portal. And the majority of those are free. It's only Sustainable House Day that has a cost associated. If you are looking into doing any retrofitting, or you're just interested to see the energy efficiency of your home, the Miley libraries have thermal imaging cameras that you can borrow for free. So you can, look around your windows and look for where there might be drafts or areas that can do with some fixing up to improve the efficiency. They also have induction cooktops, as well as home energy and water efficiency kits. So if you want to borrow any of those, they come with instruction kits, and they're a really great thing that you can do. So we will get to the questions now. So let me just have a look.
Right, have we had any questions, or would people like to ask questions?
Do you do your company do many designs for retrofits of existing homes, or is it mainly new homes that your company see?
So I very much do a lot of retrofitting and renovation of existing buildings. I believe that it's one of the best ways that we can create a more sustainable future. So my view is that there are a lot of houses out there that are, let's say a 1-star rated building. And if we could improve those 1-star buildings to, say, being a 4 or 5-star building, then, and we do that, as a community, as a population, then we will, do a lot better than building the occasional 6, 7, 8-star building. So in relation to my building, I'm a very strong advocate for retrofitting existing buildings because we do have a bit of a knockdown rebuild culture in Australia. And when we do knock down and rebuild, even though we might be building a more efficient home in the place of the one that's being knocked down, all of that building is the building that's being demolished ends up more or less in landfill. Some parts can be recycled, but a lot of it goes into landfill. So in relation to my practice, yeah, we definitely do a lot more renovation and retrofit of existing buildings. And you're welcome to visit the website if that's of interest to you.
Yeah, great. Thank you. Another question. So for most people, would you recommend going with a designer or an architect, or do you think that's something people can do themselves if they're willing to put the time in and do the research?
Well, I guess I'm an architect, so I'm going to advocate for architects, but it is a case by case. There's a lot of good building designers out there too. I'm not one to say, there are one's better than the other. I think if sustainability is your goal, and I believe it should be, because I think a sustainable house gets you a house that is more comfortable to live in. It should be a house that is more affordable in terms of the energy costs. So you may pay a higher price up front to get the better insulation, the better glazing, all of that sort of stuff. The long-term benefits will be a more energy efficient home. So look, I think my honest answer is it's a case-by-case thing, and I would just be interrogating who you're looking at getting for the design of your house as to what they know about sustainable design practices, and visiting other projects that they've done and just understanding their philosophy, I suppose. How do they think? What do they think is important about environmental design? It should be an engaging conversation. It should be something that's not just set and forget. It should be, what do you do about, what's your view on gas? What's your view on passive solar design? Do you advocate for solar panels or rainwater tanks? All these sorts of things. So, don't be afraid to ask silly questions. Find out what their views are, and if you're comfortable with them and you feel that their approach, meets your requirements, then by all means go with them. I don't think doing it yourself is ideal because I think there's a technical aspect to it. The compliance issues are really important. You do need to know what you're talking about, but that doesn't mean you have to be a passive participant in all of this. By all means, read and do your own research, but I would definitely get an expert or a design professional of some sort to do the design of your building.
Yeah. No, thank you. You've sort of touched on this next question a little bit, but how do you suggest people find a designer or an architect who is sustainably minded?
That's a very good question. So I don't know your area as well as I know my own area. I would be very aware of greenwashing, because there are, most architects will claim to be green. Most designers will. For instance, the way that I find builders for a project is I actually go for a walk in the local area. I actually just walk around and just see who's doing what. And that's my first port of call, is just see what's happening locally, because if they're doing work in the area, that means they're sort of engaged in the area. And if what you're seeing looks good, then, chances are they're going to do a good job for you. So just keeping it local, I think, is really valuable. If you're sort of wanting to go a bit further afield, then obviously website and all that sort of stuff. But I wouldn't just go with the first architect that you look at or designer. I would definitely create a little short list. Probably to your point, like when I have potential clients contact me, you don't get much of a brief. You don't get much of an understanding of what the client is looking for. So, which is kind of understandable. But I think if I would encourage people who are looking to get an architect or a designer or whatever to do is, just think about what you're actually trying to achieve. So that when you start the conversation with an architect or a building designer, you've got some basis to kind of interrogate that person and find out whether you're on the same page. And that will help the architect and the designer engage with you. And if you get that synergy, go for it. Really trust in the process and you'll get a good outcome, in my view.
Yeah, great. Thank you. That's all the questions that we have for tonight. So we might wrap up there. Thanks everyone for your time. I hope this has been informative and helped to answer some of the questions that you have about designing houses and retrofitting houses. And a big thank you to Anthony for lending us his expertise and experience for tonight. There was some really great info in there. Thank you as well to Sarah from Renew for the behind the scenes support. So before we close the event tonight, I'd like to remind everyone they can register for upcoming workshops, both online and in person, in the Living Lightly series on the CAP, the Community Action Portal. So we'll put the link to those in the chat. And just a final reminder that this webinar has been recorded and will be available in the coming weeks on the CAP as well. That's everything for tonight. Thanks again for coming along and hope to see you again in the next one. Bye.